Well, I just want to explain the result of midterm exam. Total 23 students actually presented there in the exam. I think one or two actually dropped it, right? Jimin, I think she didn't appear, right? So maybe. And the full credit is 110, and the average was 73, and the median is 79. So that's a kind of very wonderful distribution, right? So I think I kind of gave you very wonderful, well-designed and organized midterm exam, I think, right? And the maximum is 107.
Wow. Wow.
So, yes. All right, I'd like to disseminate before starting. All right. 희건이, 기용이, 태규, 예빈이, 네. 선정이, 세윤이, 세윤, 브레이크 댄서. 네. Good job. 대현이. 없어. 승주. 현이. And Delphine. 경현이, 준태. 왜? 힘을 와. 이 정도면 공부는 돼. And Michael. 희철이. 예린이. 효빈이. 미소. 수영이. 유지원. 지원이. 탕. 아리카. And Sam. You're late. All right. Well, I think you guys had wonderful results. So, well, this is at the end. Well, actually, you guys have one more exam. Well, this is around the 20%, right? I think the final team is 30%. So, well, I think if you think you don't have good grade, well, just study hard and have good grade. And if you have good grade at the final term, well, we can have good grade. So, just don't be disappointed.
네, 알겠습니다.
시험도 못 받았나?
이름이
유재환.
아, 재환이. This is J1. I think I'm J2. Well, I really did hard, and I think there are many generous grades actually applying. Well, as I already taught, just don't leave the answer section. Put it something if you know. This is not the GRE type exam. I never ever decrease your grade. So put it anything. That is very, very important. And the final term exam, well, it could be accumulative exam.
Wow.
Wow. Think about that. Well, I'm actually, giving you very interesting environmental issues. And I'm just giving you kind of good story when you have blind date and you can actually give very nice talk to your future girlfriend and boyfriend. So how can you forget this? And even I am giving you, chemical equation, and also you can actually estimate the digits using simple, theory. That is a wonderful thing, I think. So, well, just don't be disappointed. Study hard, and you can get over. All right? Okay. If you have any, complaint on your grade, well, drop by my office. And well, I think most of you may be satisfied because I just put some more generousness on your grades. I'm not the guy who are judging you and want to dehead your But anyway, if you don't satisfied with your grades, you think you are not well evaluated, drop by and we can talk. And my assistants actually can, get prepared to the pain. Actually. Okay. All right. Before starting, let's 수영. Okay, you come here. All right, good job. Impressive. 희영이, 현석, 준태 왔고, 효빈이 왔고, 강진이, 마이클 왔고, 예빈 왔지. 좀 많이 틀리네. 기웅이 왔고, 수영이 안 왔지? 희건이 왔고, 준태 왔고, 효빈이 왔고, 예은이, 마이클, 예빈, 아리카, 세윤. You better change your name to break dancer. 재환, 우기, 우기 맞나? 여기서 왔고, 건이 왔고, 준혁이, 태규, 혜린이 맞지? 저기, 선정이, 승주. 네. sorry. 경현, 탐, 쌤, 여빈. 오케이. Now, I'm very happy because I can teach this part, because this is really my major of study, research work right now. As an environmental scientist and environmental engineer, I really have very strong interest in the fate of contaminants, environmental contaminants. If you know the fate of yours, what would you do? If you know breakdancer, if you know your future, maybe 5 years later, what do you want to do?
Okay. At first, I will plan very seriously application because I know the time to make. I will cut down time very.
You know your future in 5 years. You want to carefully plan.
That's work, not work late and just 5 years.
I think you're very diligent and very dedicated students. If I were you, I know my destiny and my fate in 5 or in 10 years. I actually didn't do anything because I know what I will do tomorrow. Why do I need to plan? I just lying on the bed and wait. I need to meet him. Maybe I can see him around 6 o'clock. So I don't have to worry about to make some kind of relationship actually. And I know that girl hates me, but maybe in 5 years she loves me. That is very wonderful, right? So knowing fate is very, very important. If you know the fate of chemical contaminants emitted in the world, well, you can do just like this. You don't have to do anything. But as an environmental scientist and environmental engineering side, well, you know the contaminants fate. What you can do is you can give much better and best actually consultation, and you even can give very best technology to your clients. Is it right? You know the fate of contaminants, and you can talk to him or talk to her. The owner of Starbucks, Woojin Lee, she was a Starbucks owner. I don't remember who's the owner. Oh, she was a consultant there, right? Well, anyway, she can give very wonderful and nice environmental decision to the client. So, how do you know the fate of contaminants? If the contaminants emitted to the environment. Think about that. Our Earth system actually included 3 big phases. Right? Which one is gas? And the other one is water. And the other one is solid. So contaminant could be gas form, or could be aqueous water form, and could be solid form, right? You just want to know, once the contaminants discharge into the environment, how the contaminants disappear, how the contaminants kept in the environment. That is very, very important to you. Fortunately, the scientists already, researched about the relationship, the contaminants' fate in this environment. We will learn about this basic, simple environmental theory, chemical theory. Well, most of you already know very simple chemical theories. I will just introduce you, and then I will explain how it works. And I will give the example. how this simple and this, very straightforward equation can be used for the estimation of or for the prediction of the fate of environmental contaminants. Wow. I think I already gave you how to write the paper and submit it and publish your paper in Science and Nature. Did I? Right? I even gave you how to win the Nobel Prize. So, can you? All right, let's start the fate of organic compounds. Question here. What happened to the organic compound when it is dumped into the environment? Well, contamination, occurred. Very simple. But the fate of the organic compound actually depends on the physical and chemical properties. Well, all the Chinese, probably, if you know the enemy, you can win the game. This is very, very important. Know the information of the enemy. If you don't know, never ever go there. You lose the game. This is very, very important. So, if you want to start the environmental remediation or environmental treatment, the important thing is you should know the information of the enemy, which means the property, chemical, physical, or biological property of contaminants. This is very, very important. Think about this. Well, if the methane, is methane contaminants built in? What do you mean by the kind of CH4? Higana, what do you think about this? What is the standard to distinguish this one is contaminant and this one is not contaminant? Sam? No? Or take you?
Distinguish? How distinguish?
Yeah, what could be the standard of the contaminant?
Or whether it harmful us or not?
All right, that's good. If so, is methane contaminant based on your standard?
No. Methane is harmful or not?
Okay.
Where it is, when it is.
Mm-hmm.
Yes. So methane is contaminant, and on the other hand, it is not contaminant.
Yeah, that's my goal. Well, actually, methane is very useful. It can be used as a fuel. Methane hydrate. It is kind of optional, next generation fuel source. So that is the reason why the Korean government are so freaking, out for the methane hydrate at the Ulsan Basin, East Sea of Korea. That is very, very important. And also, methane is kind of, greenhouse gas. It can cause, greenhouse effect. Well, compared to the CO2, carbon dioxide, methane is 20 times powerful than CO2. So, in that, reason, well, we can say methane could be contaminant, or methane could be very useful fuel. It is just like the ozone. Think about that. Ozone stratosphere. Well, it could be very, very good guy. If we don't have enough concentration of ozone in stratosphere, what happens is you are foliated by UV. But at the troposphere, if you have high concentration, it can cause you very severe and serious health problem. So that concentration and the episode could be very, very important, right? So in this case, methane could be, methane is not the source of the fuel. It is just like the very, smelly, contaminants. But the important thing is, if the methane is bubbling into the water, do you think that can fully contaminate the water? Michael, why?
Because there is no reaction
What kind of reaction?
that will affect the quality of water. Chemical reaction.
Once contaminants can cause effect, it should be dissolved in water, right? So methane cannot be easily dissolved in water. So it cannot be fully dissolved in water. It cannot cause contamination. But methane can be easily evaporized, right? So methane will not cause water pollution, but it can cause greenhouse effect, although it emitted to the water or emitted to the gas phase. But what do you think about DDT contaminates the water? Have you heard about the DDT? Well, I just talked to some examples. DDT was very useful chemical compounds. Because of the DDT, a German chemist actually got the Nobel Prize. DDT is kind of, insecticide. Maybe 50 years ago in Korea, it is around my grandfather's generation and my father's generation. They are using DDT to expel the lice on their head. If there is lice, just take a pinch of DDT and sprinkle it on their head, and the lice actually expelled from your head. So that is very, very wonderful, expellant. Or nowadays, do you like dog?
Dog?
Yeah, dog. Well, Korean loves two ways. Sometimes they want to eat the dog meat. Sometimes they really like the dog. Well, dog really have flea in their fur, and the expellant actually include chlorine in their chemical structure. DDT also include chlorine. DDT can be dissolved in water and very toxic, and it can cause very severe health problem. So DDT could cause water pollution. Because DDT can be dissolved easily, relatively easily in the water, it can be pollutant. Methane, although this could be a pollutant, it cannot be easily dissolved, and it cannot actually contaminate water because of its characteristic. So depending on the characteristic, the fate of chemicals can be totally different. You really need to know this. Think about that. Your client just dropped by your office, and he was worried about the contamination. The main contaminants was very vapor pressurized compound. If you just give him some sort of water contaminant technology, can he be totally satisfied? Before starting your consultation, you really need to know your enemy, the contaminant's characteristic, physical and chemical properties. These physical and chemical properties actually give you the information, very basic information of the fate of the contaminants. This is very, very important. All right. And also DDT can cause big problem for biota. So it can contaminate you and contaminate friends on the earth. So we can solve these environmental questions, the fate of contaminants, by using equilibrium partitioning of organic compounds between environmental phases. Let's say I already talked to you 10 peninsula, crude oil spill, actually. This is too much. Well, there is very big, crude oil spill in the world. Well, actually, I really don't know. This is Alaska. Let's say this is Alaska in the United States, and there is very big place. William Prince William. There is some kind of iceberg here, and the oil tanker called let's see, parties. Exxon parties. Exxon is a very big oil company. This tanker actually cracked down because of this iceberg, and the crude oil actually spread over the Pacific Ocean, and the crude oil actually found near the shore of Mexico. Interesting thing is, this is Korean Peninsula, Taean area. Here, the Samsung oil tanker actually cracked down, and the amount of oil spill is 1/3 of this Exxon party's case. Wow, this is too much, right? And here, this is Korea, and this is United States, and the very big, ocean, Pacific Ocean, called Pacific Ocean actually exists. Interesting thing is, Taean area, this West Sea, Yellow Sea actually surrounded by Korea and China and even Japan. So the crude oil spilled here actually go nowhere, just to stay here. Don't you think so? But think about this. The crude oil amount 3 times higher. Exxon Valdez, the oil tanker cracked down, and the crude oil actually migrate to the Mexico and Gulf area here, and it was around I think 30 years ago this accident actually happened. But nowadays, researchers can report this crude oil still found at the seashore of the Mexico. It was 30 years ago. But here, when did this accident happen? Is it 2007, 8? Anybody who went there to clean the Taean area? Is there anybody here for cleaning Taean area? Nope. At that time, you guys were middle school students, right? Let's say 5 years. After the oil tanker cracked down, just 1 year had passed. Korean government said no crude oil, appeared. So all the crude oil gone, and the remediation occurred by the natural handling power. The amount, let's say this is 30,000 tons, and this one is 10,000 tons. 30 years before, and 1 year before, and the researchers here reported still they can find crude oil 1,000 miles away. Mexico, they can find it. Korean government just reported. 1 year later, no crude oil, found. Do you think this is logical? And this place is even surrounded by the continents and the peninsula. And this place, nowhere, just the Pacific Ocean. So my hypothesis was and is there are still tons of crude oil in the middle of the sea, actually. But I really don't know. The God really loves Korea, so it can be well kept in the middle of the ocean. Maybe our kids, 100 or 200 years later, they can find it as a oil well. But I really don't know what happened here. For most of the fishes, you guys really like the Korean sashimi pei. And mostly the Western galaxy, actually. So I really want to take it out and take some test and just check the hydrocarbon concentration, actually. So how can I estimate the crude oil concentration here as an environmental scientist? If we know the characteristics of crude oil, we can estimate what portion exists in the water and what portion kept in the sediment and what portion can be evaporated. Well, think about that. Let's make this system very simple. We can just make some, artificial seawater, which is 3.5% sodium chloride solution. Well, we just put, and make the solution here, and then put some soil here. Well, if you want that, you can take some soil from KAIST, but you should be very, very careful because KAIST soil is very acidic, but most of the seawater soil, sea sediment is around 6.5. Or you can go to the west side and take some sample and put it in here, and then inject crude oil. Mix it well, shake it well, maybe 1 hour with your biggest power, and then put it 1 day or 2 days. And there might be some kind of equilibrium, reaching. Well, let's say this is crude oil particle. Crude oil actually is this type of, long chain hydrocarbon, right? So this hydrocarbon can be dissolved in seawater. Right? So there may be some kind of dissolved hydrocarbon crude oil here. And because this is soil, maybe the sediment, the solid, the crude oil can be dissolved or dissolved on the surface of the sediment, right? So let's say the concentration of crude oil in water is CCW. And then let's say the concentration of the salt on the surface, say CCS. And what else can we consider? Can you smell something if you just drop by a gas station? Right? So that means crude oil or oil can be evaporized. So this one can be evaporized. Let's say CCG. Is there any portion we need to consider to calculate the total mass? Maybe this crude oil itself can stay as just itself, non space. So let's say this crude oil here, CCC, right? All right. The concentration of crude oil before spiking, right? Let's say this one is CC0. So CC0 could be CCC plus CCG plus CCW plus CSC, right? If we follow Newton's mass conservation law, this should be right. Right? So based on this equation, we can actually estimate the fate of crude oil in Tian Peninsula. Right? I did it, actually. I did it. We know the total tons of crude oil discharged from the wrecked ship. It was 10,000. I calculated using some simple chemical equation, mostly partitioning, relationship equation. And then this one is just a so 70% cannot be, found. Where are they? So my basic hypothesis was and is it is in the middle of the sea. Hopefully, our kids 100 years later can find it as a oil well. So this is very, very important. From now on, you guys will learn about the how to calculate the concentration of each phase, because this is very, very important. And this can actually give you the very basic information on the fate of contaminants. And also, important thing is, this is just a fate. And the one thing you want to know, if you want to really be a good consultant, what could it be? This is just a fate, right? But for the contaminants, the transport is very, very important. So, using this one, you know the fate. And you should know the transport. Think about this. If this crude oil, luckily, stay at one place, well, this is okay to us. We just want to know the fate. But what if the very, serious environmental disaster happened? Let's say tsunami. It can, dramatically move to other side. Well, think about that. All right, this one was actually, the ship was cracked down near the Tian area. Fortunately, or this one suddenly moved to the near the shore of the China. Who cares? I'm very sorry to the international students. As a dedicated Korean people, who cares actually? Or if it is just going to be this side, who cares? So transport is very, very important. If you know the transport and the fate of contaminants, you can start the environmental consultant. This is very, very important. And also the fate and transport can be estimated by mathematical, way. This is one of the wonderful things that environmental engineer only can do. Right? Okay. So we can solve these environmental questions by using equilibrium partitioning of organic compounds between environmental phases. So think about that. Well, DDT, how much DDT can be, stayed as solid or as water? If DDT never ever dissolve in the water, why do you care? Just using the tongue and take it out and then drink the water. But DDT can be dissolved. You don't want to drink it. Think about that. If you just put some diesel fuel in this nice cup of coffee, if I use some kind of physical tool and I remove the diesel fuel, if I gave it to the pin, and can it drink it? Let's say this is new coffee. I never ever touch my lips. Never ever touch this. And if I give it to her after removing the diesel fuel, does she want to drink it? Because she's very brilliant and bright. She knows diesel fuel is non-polar, but it can be very small amount of concentration can stay as in aqueous phase. So she cares about her health, and she doesn't want to drink it. You know. So knowing the characteristic, physical and chemical characteristic of the chemical compound is very, very important. Think about that. There is very toxic chemical, if you just hear it. And the toxic chemical cannot be easily dissolved. It cannot be dissolved. If so, do you guys worry about this to take it? It just, moving out from your body if you have plenty of time. But most of the toxicants and toxic chemicals are very well dissolved in your body. It can actually cause effect. So we can call them toxicant. Right? Alrighty. And finally, we can define various physical and chemical properties that control the partitioning coefficient between the phase. Think about that. Air, water. This is one nice cup of soju, 10 milliliter. Do you know the volume of soju shot glass, Korean shot glass? You know that. It is around 25 milliliter. And if you put 25 milliliters of soju here, and you seal the mouth of the cup, and what happens is the alcohol actually vaporized. Right? So in air and water interface, vapor pressure and water solubility is very, very important. Well, just to think about that, you have 100% alcohol, right? The alcohol 100% actually dispersed in water, and some of them evaporized. So alcohol dissolution, alcohol evaporation is main reaction mechanism in air-water interface. And what about the water soil? You don't have to think about the water soil. Let's say here is DDT, which is very nonpolar chemical compound. Maybe some portion can be dissolved out in water, and maybe some portion can be, evaporated, right? And sometimes if this one is not the contaminant, if the soil, the chemical compound can be absorbed on the surface, right? So water-soil interface, air absorption and water solubility actually is the main characteristic you want to know. And soil water, the same thing. Think about the. This is the chemical industry. There is very big step. The contaminants actually discharged every day. So the owner of in this factory actually want to remove these contaminants. So they just bypass this chemical film and put it through the solid catalyst. This is solid. So the solid, maybe let's say activated carbon. You smoke. If you just take it out the filter of the cigarettes, you can sometimes find the activated carbon, which is very good absorbent. So the contaminants, gas can be absorbed, the chemical contaminants absorbed on the surface of this activated carbon. So absorption is very, very important. And also the chemical film itself has gas phase contaminants. It can be evaporized here. So vapor pressure and absorption is very, very important for the reaction mechanism for this interface. All phases with biota. Solubility in fats are very, very important. So this is the reason why you guys want to so care about to lose your weight. everybody wants to get diet. Even 4 years old, my daughter, sometimes I just talk to her, wow, you eat a lot. She'd talk to me, well, I will start my diet from, tomorrow morning. Even 4 years old daughter just told me she wants to have diet. But why? Why do you want that? Well, as an environmental scientist, lipo, which is fat, is very, very important. So most of the toxicants are the organic chemicals. They are actually non-polar. So it cannot be easily dissolved in porous order, just like the water. But it can be easily dissolved in the fat. So if you are on diet, you want to lose your fat, right? So there are so many toxic chemicals floating around in the air and in the cup of coffee, maybe. And if I have a lot of fats in my body, well, those toxicants actually can be easily accumulated. So you can be easily dead. So that is the reason why the fat guys and fat people can be easily die. So if you want to live with health, just lose your weight. That is very, very important thing. So all phases in biota, solubility in fats, we call it lipoplastic. The heinous and toxic chemicals always love fats. So that is the reason. Well, fat can cause you very serious lung, heart disease. But as an environmental scientist side, I think the chemicals floating around in our environment easily can be accumulated compared to the lean guys. So lose your body weight. All right. I think so if these various physical and chemical properties are known, then we can predict where the contaminants can stay. Well, think about that. If the contaminants are very water soluble, which is polar chemical, it wants to stay in water, polar area. But if the chemical is non-polar, most organic chemical compounds, hydrocarbons, well, those are non-polar. So it wants to stay your fats, non-polar, area. So well it stays, and also how much amount can stay as a fate. You can actually estimate this. So that means you can start your consultation. This is very, very important. So as I already talked to you, what is the most important concept in environmental science, chemistry? It would be mechanics and dynamics. Equilibrium, right? But think about what is important for the before starting your environmental consultation. Well, if you know the fate and the transport of the chemical, you can start your consultation. This is very, very important. All right. Any question? Any comments on the introduction material today? All right.
챕터 제목이 왜 얼가닉 얼가닉 그거 말고 왜 폴루턴트가 아니고 왜 얼가닉 컴파운드인지.
Well, his answer was why this one is environmental chemistry, environmental science. Why the chapter title is not the organic contaminants, organic compounds? Well, as I already talked, we never ever judge the people before righteousness of his or hers. This is very, very important. As we already have talked, as you already said, methane could be heinous, or methane could be very beneficial, right? It depends on different episode and different places. It depends on different amount. So it could be very beneficial compounds, and it could be just like the toxicant. So the author of this text, he just consider about that. So he never ever said that is contaminated. Sometimes it could be, essentials. For example, chromium-6. Well, in your liver system, chromium-6 is very, very important enzyme, composition actually. But the important thing is, as I already talked about, if you increase the dosage of chromium-6 in your liver by 10 times or 15 times, it could act as, toxicant. You can be dead. So concentration problem. Got that?
그렇다면 non-organic 프로덕트에 관한 사람은 다르지 않는 거예요?
That is very, very, excellent question. Because Ron Heights is organic chemist. Well, I think organic chemical, inorganic chemical. There are so many different types of inorganic chemical. For example, heavy metals and as I like chromium and lead and even radioactive materials can be very, very I'm not just focusing on the organic chemicals because I'm not the organic chemist. So we will go with much more on the inorganic chemicals and also radioactive materials. Any further questions? Okay, thank you very much. And if you have any complaints, and just drop by. All right?